Okay, thank you. Well, thanks for the opportunity to visit with you for a minute. I don't have a nice video out in the field, but hopefully I have enough pictures to show some of the research we've been doing on grazing and pastures. I'm with the USDA Agriculture Research Service in Logan, Utah, Forage and Range Lab, and I'm going to talk about some team research we've been doing that we're appreciative to the granting agencies who have helped us with this, Western SARE and NIFA OREI. To give just a little bit of a background, we started doing research at the Lewiston Grazing Center back in 2012. And we started with a project where we were looking at beef steers, and we were grazing them on tall fescue. It was either fertilized or tall fescue unfertilized, tall fescue in a mixture of birchfoot trefoil, and tall fescue with alfalfa. We grazed them throughout the year on a rotational basis, and then we looked at the gains from them. And what we found was that over the course of the season, does this work? Can you see? Earl, can you see my pointer?
Yeah, we can see your pointer.
Okay. So over the course of the season, we found this red line here is the tall fescue birchfoot trefoil, and these are the cumulative gains. And eventually it passed the alfalfa, which was the blue line, and it ended up having the highest gains. Here's the tall fescue fertilizer. Here's the tall fescue without fertilizer. And I don't have a slide to show the economics of it, but based on that last question, I'll just say that we ran the economics of that. And these two treatments with legumes received no fertilizer at all. And they ended up being the net return on that was that the birchfoot trefoil had the highest net return, very competitive, and even beat growing corn, wheat on that same ground under an irrigated situation. So we were happy with those results. However, we did not get the gain that we had predicted we would get. And so we started looking a little closer, and we noticed that our energy of our grasses, monocultures, with or without fertilizer, was down here, where our energy of our grass legume mixtures was higher, but we found a little slump here. And so we wondered what if we used a high energy grass? Could we bring up the energy in a mixture of legumes and bring the energy up this direction, and if we could get better gains? So we started thinking about this, and we came up with a new research thought that if we used high energy grasses and tried to combine it with the condensed tannins in the birchfoot trefoil, if we would get this complementary effect and improve intake and livestock performance. This is a large group effort. I have slides here that have a lot of information on them, some tables with some numbers and stuff. I've included them just in case somebody wants to go back and look at them. I'm not going to go into a lot of details, but this is being recorded, so I thought I'd include it for those who might have an interest. A lot of people involved in this project. However, maybe our most important team member was Jersey heifers. We moved from a beef cattle model to a dairy model. That's the way we were able to get it funded. Our funding agency said Jerseys were the grazing cow, the grazing breed, and so we said, great, we'll use Jerseys. And they end up being a great team member. They're easy to work with. So what I'm going to present here is the results of several graduate students who have been on the project, Marcus Rose and Jacob Hadfield, and just kind of go over some of the things they found. They've now graduated and moved on to jobs, but we're going to talk a little bit about how those heifers performed and what was influencing dry matter intake. As way of background on that, we have grazing dairies are on the increase, especially organic. Dairies are in my own area are continually, we see some converting over to grazing and to organic. And so it is one of the fastest growing sectors of agriculture. However, grazing dairies always experience a decrease in milk production up to 32%, and study after study has shown that this is primarily due to reduced dry matter intake and reduced energy in the herbage, which goes back to what we were worried about. We work with a number of producers, and they also have brought up the point that some dairy breeds are more finicky grazers than maybe our beef breeds. And so a species like tall fescue, which I work with, and keep telling them no, they'll eat it, they say no, they're not eating it as well. And so we wanted to be able to test that. So just some of the things we were looking at as we started, we wanted to look at a number of different endpoints by the animals. And I'll talk about a few of those here, mostly just the forage and the heifer growth, not all the egg count and stuff like that. So we ended up then choosing a number of different grasses that range in what we figured would range in energy. With our tall fescue, bird's foot trefoil here would be our standard. We knew what that would do from our previous study. And so we have our 4 grasses in monoculture, our 4 grasses with bird's foot trefoil. Perennial ryegrass, we used a high sugar perennial ryegrass, assuming it had to have the highest energy. We used a high sugar orchard grass, which would be next, and then meadow brome, and tall fescue with the least amount of energy. This was conducted under organic situations, so fertilizer was limited. This is a picture of bird's foot trefoil, and I'll be using this symbol, BFT, for bird's foot trefoil throughout these slides. We were grazing throughout the season, and we used a 7-day grazing period with 5 paddocks, such that each 7 days these animals would move to a new paddock. And you can see here they just moved back to here. Here's the lush growth, and so by the time they get here, these paddocks will look like this again. We weigh the animals every 35 days, and in order to measure dry matter intake, we look at herbage disappearance, which is pre-graze herbage mass minus post-graze herbage mass. And we used a rising plate meter to determine herbage mass. So the first results from that heifer performance. In this graph, we see cumulative weight change, or the cumulative weight over the season. The dark line is on average all the monocultures, and the dotted line is on average all of the mixtures of bird's foot trefoil. And you can look at all these results, and what you find out is that heifers on the plus BFT increased in weight gain and average, as shown here, and they also had a higher weight gain than their respective grass monoculture in every case. So we can say that the plus BFT in the mixture did improve our heifer performance, improve our heifer weight gains. How about dry matter intake? This was the other thing that we wanted to find out about. And again, we have a very similar result as the animal gains. When we add BFT, we increase dry matter intake, not only on average, here's dry matter intake on average, but also each one of these individual grasses, we have higher dry matter intake with the plus in the mixture with bird's foot trefoil as opposed to its monoculture. And again, we had what we had thought we might see, and we did see that here. One thing that we found out was our apparent intake, this is measured by disappearance, is less than would be predicted. And we've been working on some reasons why that might be. It might just be because using the disappearance method causes us some issues with absolute values, but we feel confident in our relative values as we compare the different treatments. We wanted to know what traits were most important for intake. And we found out, we did some analysis, and we found out that basically it's fiber, NDF and ADF, versus energy, water-soluble carbohydrates, IV digestibility, metabolizable energy, non-fibrous carbohydrates. So basically we found that the pasture treatments differed in digestibility and dietary energy. Second of all, and they varied. I should say they varied in energy just as we had proposed, and bird's foot trefoil mixed with the grasses increased our metabolizable energy on average, and again for all grass mixtures compared to the monoculture. We also found that the bird's foot trefoil in the herbage and the percent of condensed tannins in the herbage and crude protein were influencing dry matter intake. So basically bird's foot trefoil was influencing that. I'm going to jump down from there and just kind of hit some conclusions so I can take a few questions. So bird's foot trefoil increases weight gains. It increases dry matter intake. Dry matter intake of the tall fescue was the same as perennial ryegrass, so I was right. Cows are eating tall fescue, but on the other hand, there were a lot of other grasses the cows were eating more of, so this producer, he was also correct in telling me that they wouldn't eat it. Fiber, energy, percent bird's foot trefoil, and percent tannin had the greatest effect on dry matter intake. And as we go all through this, we found some evidence of a complementary effect between condensed tannins and energy. One thing I didn't talk about on an earlier slide is on the monocultures, we did find that we probably had a protein deficiency. Our energy was too high. It wasn't in proper balance, and that probably affected our monoculture intake. As we've analyzed this and looked it over in 2 studies, now we found that our herbage traits explain 50% of the differences in animal performance among beef steers and in dairy heifers. So does that mean that pasture-based livestock production is 50% important, 50% based on the pastures and 50% based on cattle genetics? It's a good question, and we're looking at a new study looking at different dairy breeds to try to answer that. My final thought that I like to share when I talk about this is I've decided that a successful pasture-based producer must be both an excellent herdsman and an excellent grass farmer.